Okay, we want to go now to section 6.4. So we don't necessarily do the sections in numerical order. Remember, we just did 5.1, 5.2, 5.3, 5.4. Now we're going to skip to 6.4. But this is the order that your homework is listed in. All right, in 5.1 and 5.2, we covered rules of exponents. In 5.3, we talked about adding and subtracting polynomials, like terms. In 5.4, we talked about multiplying polynomials. So adding and subtracting and multiplying polynomials. Now, what we're going to do in section 6.4, briefly, is we're going to look at dividing polynomials. But we're not going to just open up the gates and look at all dividing polynomials. We're only going to look at two very case-specific examples. So we're only going to look at two kinds of dividings with polynomials. Here's the first case we're going to look at. The first case is we're going to look at a problem where we're dividing a polynomial. Now, what's a polynomial? We talked about that in section 5.3. It could have 1 term, 2 terms, 3 terms, 12 terms. So a polynomial could have as many terms as you wanted to have in it, 1 or more. But that's not what we're talking. We're talking about dividing any polynomial by a monomial. So in every one of these examples we're about to look at, I'm going to ask you to divide, and the top part will have multiple terms in it, but the denominator, the thing that's in the bottom, will only be 1 term. So we're talking about dividing a polynomial divided by a single term only. So what's up here could have 1 term, 2 terms, 8 terms, 15 terms. But the bottom will only have 1 term in it. Now, we have actually divided polynomials before in here. But here's what we looked at. If I ask you to work out this problem right here, 20x to the 7th, is that a polynomial? Yes. Now, more specifically, it's a monomial, but that's a polynomial. Now, in the bottom, let's put this, 4x to the 3rd. So are we dividing? Yes, because there's a division bar. Is this a polynomial? Yes, it is, but it's 1 term. Is this a polynomial? Yes, it's 1 term. So this is 1 term over 1 term. So does this fit this category right here? Yes, it does. Now, how did we do this when you have 1 term over 1 term? That was just rules of exponents. So let's do this one. How many times will 4 go into 20? 5 times. And x3 into x7, if you remember, you subtract exponents, would be x4. We're done. That is the answer to that problem. So we have talked about dividing polynomials in here already. But that's not what we're going to talk about in this section. What I'm going to do is I'm going to give you some of these where it's not just 1 term over 1 term. It's going to be 2 terms divided by 1 term. Or 3 terms divided by 1 term. Or 4 terms divided by 1 term. So I'm going to change how many terms is in the top. I'm not going to just leave it 1 term. Now, write this down and then we'll do some examples. Here's the note. To divide a polynomial by a monomial, we simply divide every term of that polynomial by the monomial. Now, let me explain what that means. And again, back that up, pause it where you need to, if you need to write, because you need to write that down. All right, so here's what this means. If we're dividing 2 terms by 1 term, here's what we're going to do. You're just going to simply divide this 1 term into that, 1 term into this one. If we have 3 terms divided by 1 term, we're just going to simply divide that 1 term separately into all of the terms in the top. So that's how you divide by a monomial. Okay, so let's look at this example right here. Write this one down. Pause the video and write this down, and then we'll go over it. Okay, you should have this written down now. So this is 18x to the 5th minus 12x to the 4th plus 24x to the 3rd, all divided by 6x squared. So what I want to do is I'm dividing 3 terms divided by 1 term. So what I want to do here is I want to divide this 1 term into this, divide this 1 term into this, and this 1 term into that. So I'm really just doing 3 different division problems. For reasons I'll show you in just a minute, I don't suggest that you try to do it in your head. It will be okay for you to do it in your head if all of them divides out evenly. But sometimes they don't all divide out evenly. So here's what I would suggest to you. Instead of dividing it out in your head, literally rewrite the problem so that it's this over this minus this one over this one plus this one over this one. So put an equal sign right here, and let me show you what I mean by that. Okay, now write that down right here. So what I did is I wrote it as 3 separate fractions, where here's the 3 terms in the top and there's the 1 term in the bottom. This is mathematically equivalent to the original problem. Now divide each one of these separately. Well, that's easy. Six into 18 is 3. x2 into x5 is x3. Minus 6 into 12 is 2. x2 into x4 leaves x2. Subtracting exponents. 6 into 24 is 4. x2 into x3 leaves x1, or just x. So that is your answer after you divide it. Now, you will see in this next example why I do not suggest you doing it in your head. Let's look at this next example. Okay, so write this one right here down. Pause the video and write this example down. Okay, now what I'm going to do is I'm going to break this up into this over this, because this is 1 term, minus this one over this one. Well, when I break this up into 2 terms, I get this. Now divide. So pause the video if you need to. So you got this over the denominator minus that over the denominator. Then 10 into 30 is 3. A3, A7, A4. B7, B10 is B3. Minus 10 into 10 is 1. A3 into A5 is A2. B7 into B15 is B8. Subtracting exponents, no, you don't have to put the 1. You would only have to put the 1 if there was nothing else left. So that one divided out evenly. I was wrong. It's this next one that I'll show you that it doesn't. So let's do one more example like this. And then remember, I told you there's 2 cases of dividing that I wanted to talk to you about. So okay, pause the video now and copy this problem right here down. The instruction still says divide, so pause the video. Okay, how many terms is in the top? 4. 1, 2, 3, 4. How many terms in the bottom? 1. So we're talking about dividing by a monomial. So how do you do that? You divide this 1 term into all 4 of these separately. So this is what that will look like right here. So let me make sure you got it. So you got this term, this term, this term, and this term. So literally rewrite it. And you'll see why in this example, because all of this is not going to divide out evenly. Pause the video and copy that if you need to. Now, one more time, pause the video now and copy this. Now, let me explain where all this comes from. So you do this one over this one, this one over this one, this one over this one, and this one over this one. Because of the adding and subtracting, it makes this 1, 2, 3, 4 terms over one term. So we break it up into 4 parts. All right, 8 into 40 is 5. X1 into X2 is X1, subtracting exponents. Y2 into Y5 leaves Y3, subtracting the exponents. So that's 5, right here, 5 x Y3 minus. Now, 8 into 24, 3. X1 into X4, X3. Y2's cancel, leaves no Y's at all. Minus 8 into 16, 2. X into X leaves no X's, but it still leaves the Y2 on the bottom. So you can't just snatch it up here because you don't like it down here. It's still down there, so you have to leave it. So see, that didn't divide out as evenly as these other 2 terms. Same with this last one. 10 over 8. 2 goes into both of these. 2 goes into 10, 5. 2 goes into 8, 4. X, there's no X's in the top. That X stays in the bottom. And then this Y cancels with the Y2 and leaves Y1. But it's on the bottom because there's more on the bottom than there are on the top. We talked about that in section 5.1. So, as ugly as that answer is, that is the answer to this problem. Okay. Now, I told you that there's 2 cases of dividing that we want to talk about. Now, let me show you just kind of, I know this is not mathematical, but let me show you just kind of what I'm talking about. So we're talking about case 2, dividing, and it's where we're going to have a polynomial. Now, instead of one term in this denominator, this is my denominator, this is the top part, this is the bottom part. In this bottom part, we're going to talk about, remember case 1 was where the denominator was a monomial. What we're going to talk about now is dividing by a binomial. So what's going to be down here is 2 terms. But it's not just going to be any old 2 terms. It's going to be 2 terms, but here's what it will look like. Now, I know this doesn't make sense to you, but it will in just a minute. So, our divisor, what's in the bottom, is either going to be x plus some number or x minus some number. That's what the bottom part has to look like. Let me give you a couple of visuals just to show you what it'll look like. You don't have to write these down. Look at these 2 problems right here. Let me make sure you got, yeah. Okay, how many terms is up here? 1, 2, 3, 4 terms. How many terms is in the bottom? 2 terms. But look at what's down here. X minus a number. Now, look at this one over here. 4 terms up here. Look at what you're dividing by. X plus a number. So, in all of these that I'm about to explain to you, you're always going to be dividing by a binomial, not a monomial like we talked about a while ago. A binomial, 2 terms, but it won't just be 2 terms. The binomial has to look like one of these 2. So it'll be x plus 3, x minus 7, x minus 12, x plus 4. So it won't be 7x plus 5. We're not talking about that. It won't be x squared plus 5. So there won't be a number in front of this x and there won't be a power right here. So how do we divide a polynomial by something that either looks like this or looks like this? Well, there's a special name or a special way to divide these two problems right here, and this way is what we call synthetic division. Synthetic division. And that's what I want to show you starting in just a second with this next video, how synthetic division works. Now, before I do that, we need to make sure that I remind you about a couple of things about dividing in general that you've probably forgotten, that you haven't seen these words in a while. So let me just show you something right here. You don't have to write this down if you don't want to. If I take 28 over 7, of course the answer is 4. But if you'll remember, we give a special name for that number, 28. Now, one name is called the numerator, and that's true, it is the numerator. But another word is called the dividend. This right here is the denominator, but it's called, in long division, we call it the divisor. Now, we call it numerator and denominator if we divide it that way. But if we divide it this way, like long division, you hadn't seen this since the 3rd or 4th grade, remember you put the divisor out here, and the dividend goes underneath there. So the dividend is what you divide into. The divisor is what's out here. Now, of course, you already know the answer to that's 4. Why? Because 7 times 4 is 28. Now, what do we call this thing right here? Remember, that's called the remainder. Now, is the remainder always 0? No, the remainder is not always 0. One if it doesn't divide evenly. But we give this 4, the answer, a special name too. And it's called the quotient. Now, when you divide one number into another, can you check the answer? Yes, you can check the answer. 7 goes into 28 4 times. But how can you check to see if it's right? Multiply your divisor times your quotient, in this case, and that should give you your dividend. That's important. So if I take my divisor and I multiply it times my quotient, I should get my dividend. Now, I don't have to account for the remainder in this problem because the remainder is 0. So what was my divisor? It was 7. What's my quotient? That's your answer. That's 4. If you multiply 7 times 4, what do you get? 28. Was that the dividend? Yes. So the divisor times the quotient equals the dividend. Now, in these problems that I'm about to show you, let me put these 2 problems back up right here. In just a minute, we're going to look at how to divide this into this. Now, we can't do it like we just did in those other examples because this is not a monomial. So this is a completely different game. So how do I divide this into this and this into this? Now remember, it has to look like this. That's what we're talking about in these problems. And I told you we're going to use a process called synthetic division to get the answer. So this is my divisor. This is my dividend. So what we're going to do is I'm going to show you how to get the quotient, which is your answer, by doing synthetic division. So how do we divide by synthetic division? That sets us up for our next video in section 6.4, part 2 video coming up next.